For example, here's a quote. And this quote is from an individual who owns one of the largest engineering organizations in this country, totally dependent on the work of engineers. And he said, whenever I find an engineer in my organization, I sack them on the spot.
What?
I am so disgusted with engineers.
Tech Society is a regular podcast exploring entrepreneurship and innovation in the tech world of today. We interview leaders in different fields and share their nuggets of wisdom on this show. We have here today Professor James Trevelyan. I was actually a student of James's almost 15 years ago when I was studying my mechatronic engineering degree. It was great to catch up with him and see what he's been up to. James covers his startup, Close Comfort, which he grew after retiring from the university. He gives us great insights on what it really means to be an engineer, and that answer might not be what you expect. Good afternoon, James. Where are you?
It works. Oh. I'm on a farm. I'm on a farm near Wandering.
Oh, wow.
Finishing my lunch.
Thanks for having a chat with us. It's good to see you again. I was actually one of your students 15 years ago at UWA. I was one of the earlier mechatronics students back in 2008.
Brilliant. Good. It's great to see students doing wonderful things.
It's been a long journey for me. And I remember when I first came to university, you gave a talk to my class about what an engineer really is and what they really do. And it seems that you've continued that kind of line of thought, even in your latest TEDx talk that I was watching recently as well.
Yes, I've done a lot of work since then, but yep, you're quite right. That's been my passion.
Just jumping straight into it, do you still find the understanding of what engineers actually are and what they do, is that kind of still misunderstood by the general public?
Not only by the general public, but by engineers themselves.
That's true.
And it's really fun, you know. There's two or three things. One is that a lot of engineers, you're taught that engineers solve problems right from day one. Well, of course, it's a little bit arrogant because everybody solves. Somebody who's driving a car to work figures out which way to go and where to park and all these sorts of things. This is problem solving too.
Yeah.
You know, and really, I eventually realized that good engineers, actually, the thing that distinguishes a good engineer is they know how to avoid problems. and having to solve a problem is what happens when you made a mistake and overlooked something.
Yeah.
Which, of course, it does happen from time to time. We all make mistakes. But, you know, so there's one of the myths about engineers. Engineers solve problems. No, good engineers know how to avoid them. And of course, the other classic one is that engineers build things. Of course, most engineers wouldn't know how to. You know, even building a backyard barbecue can be a challenge, let alone fixing your car.
I struggle with IKEA furniture all the time.
The big myth about engineering is that it's like a solitary performance. Engineering is collaboration, collaboration, collaboration. And it's all about collaborating with other people. And that's the crucial aspect, which is missed so much of the time in universities. And it's a really tough adjustment for many young engineers who suddenly find that getting people who are disinterested, bored, tired, want to go home, and getting them to do things is really hard. They always want to take shortcuts.
Yeah. Wow, it's hit the nail on the head there, I think. When I entered the industry, it was jarring to say the least. Rolling onto that, I find that a lot of from your TEDx talk, a lot of what you do in engineering has a very human purpose to it. You know, it helps societies, it helps the developing nations, the landmine stuff as well. But here in Perth, we have a strong focus on, you know, mining, heavy resources, heavy industry, and I feel that there's too much of a focus on it for the engineers of Perth, the new graduating students. I myself was one of them. I went straight into mining because there was nothing else to do as an engineer in Perth. What do you think about that? Oh, they paid us extremely well. So that was a good motivator. But again, yeah, No. So ultimately, a lot of engineers in Perth, in WA, become paper pushers, project management. There is collaboration, but it's ultimately pushing Excel sheets back and forth, getting things filled out. Now, wasn't as fulfilling as the stuff that you've been talking about, James. So, what's missing there? What can we do in WA to make engineering more fulfilling for the young engineers?
Well, it's all about expectations. You see, collaboration involves lots of paperwork, particularly on large projects, because paper and computers are the means by which we can remember information. And remembering that information and getting people to use it, getting people to use it is the hard bit. But remembering is terribly important. So collaboration is time consuming, and all that paperwork is really part of collaboration. So it might be surprising to you to understand that even when, for example, we were doing the robot sheep shearing project, most of the time it was the same. We were writing reports, writing specifications, and it seemed frustrating because, you think, well, so much of my time is tied up with, correspondence and gaining approvals and all this sort of things, even on an R&D project. So that's why it's all about expectations. And the sad thing is, because the focus in universities is on engineering science, and 95% of the curriculum is engineering science and mathematics, that you think that that's what the job is going to be involved, and when it isn't, you get disappointed. The experienced engineers that I've interviewed over the last few years, and I've interviewed now about with my students over 300, the really senior and experienced expert engineers gain their satisfaction from the challenges of collaboration. Let's say, really, when you think about it, getting people to collaborate effectively and getting the job done on time, on budget, that's the challenge. That's a much tougher challenge than any of the technical issues. The technical issues are so simple by comparison.
The human issues.
After a couple of years, the technical issues get boring because we've done them all before.
Does anyone actually conquer that on budget challenge?
Pretty hard.
Well, that's a good question. So let's go back to one of the experts that I always hark back to, C.Y. O'Connor, who built he organized the Goldfields water pipeline. It's really worth going to the Mundaring Museum to see some of the artifacts and some of the pipes. And when I was a student, I traveled across Australia on the train, and I could still see sections of his original pipe in use. Now it's all been replaced by welded steel pipes. But that, as an example of an engineering project, think for a moment, all right? Western Australia at the time was the most isolated backwater of the British Empire, about as far from the centers of engineering and technology as you could possibly get. C.Y. O'Connor built a pipe that was 4 or 5 times the size of the largest water supply pipeline then in use, and 6 or 7 times longer than the longest water supply pipeline, which was between Manchester and the English Lake District. And that's an enormous degree of what we call step out in the oil and gas industry. You might have heard that term, when you go beyond accepted technology. Now, there was no map when he started. There were no weather records. But he had to estimate what the project would cost. In the end, the project came in at only 8% over the budgeted cost, only 8%.
Incredible.
It was a year late, and that was because of missing a fault underneath what is now the Mundaring Weir. It was a very unusual vertical fault that was missed with drilling. And that was something which they just had to fix. They had to excavate the fault and backfill it with concrete to prevent water from leaking under the dam. And a lot of the delays were caused by delays in getting funding, which is inevitable given a project of that magnitude. And think about a multi-billion-dollar project being undertaken from a small country town, as Perth was in those days. Around about 20,000 people living in Perth and 80 newspapers. 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 80
Mhm.
and all of the newspaper proprietors were relatives of those in Parliament. So, of course, and the contractors, all the contractors, they're all related, the same families. Now, O'Connor was brought in as an outsider, and he was brought in as an outsider because John Forrest, the Premier at the time, realized there was so much corruption in this community that he could not trust any of the locals with this huge responsibility. And he brought in O'Connor, who's really experienced in working with tough environments. And of course, O'Connor, the first thing he did was clamp down on the contractors and refused to authorize payments unless they actually did what they promised. This was something new in the Perth community at the time, and boy, did they complain. They made life extremely uncomfortable. And it's sad because we still have this culture of corruption. Unfortunately, in some areas of engineering in Perth and Western Australia, it's still with us today.
Wow. Sounds like the human element is always the most complicated in engineering.
Absolutely. And the most satisfying when you get it right.
I find that this will follow on from another question, but my own path has moved from engineering into programming. So as Tech Society, as Ninja Software, we're software engineers now, and I graduated as a mechatronics engineer, so I have the experience in both mechanical, robotics, control systems at some point. As I move towards programming, there's something more fulfilling about being able to build things quickly, effectively, without bureaucracy in the way. I noticed in your TED talk you were talking about similar things. Programmers, engineers are becoming programmers. So why do you think that is? And what are your thoughts on that?
Well, thank you for asking the question. It opens up many cans of worms. So I'm going to start with something that many engineers feel a little bit uncomfortable with, and that is language. The language that we use every day.
English,
and you talk about tech society.
Yeah.
For this talk, I began to ask people what they mean by technology. You ask the average person in the street. And what came back was really interesting. Well, it has to run on electricity and it has to be complicated.
I've had this,
and preferably involve software.
I've had this argument. I was in a boardroom and there was a jug on the table and we were arguing the definition of technology. It was for a STEM award. And I said, well, technically that jug is technology. Sure, it was invented thousands of years ago, but it is technology.
It's cutting edge. At a certain point in history, it was cutting edge.
But that might not actually be your definition, but it was definitely mine.
The crunch point is this. Have a look at the pages of the Australian Financial Review or any financial newspaper around the world and see what they mean by technology, because they all have tech sections, right? Just today, there was an announcement of a new venture capital fund that to provide money for startups in Australia. And they've announced their first round of, I think, a dozen or so startups. They're all software companies.
Yeah.
So I ask a rhetoric question. How many gigabytes does it take to produce a mango? All right, it's a ridiculous question, right? But today, around the world, practically all of our so-called technology investment is going into software and apps. Right. It's not just in Australia. And the result is that our productivity growth has slipped to near zero. If you want an explanation as to why there are so many dissatisfied people in countries like America, Britain, Europe, and so on, complaining about living standards that are not improving. They're quite right, they're not improving. And the reason why they're not improving is because our productivity is not improving. Our productivity used to grow at about 1% a year in real terms. Over the rate, and means that incomes grew just a little bit every year above the rate of inflation, but it was still, life got better for everybody year after year after year until about 2005. And many people argue that the global financial crisis of 2007 and 2008 was caused by technology overreach. In other words, the productivity growth suddenly stopped. And it's really interesting to speculate why that's the case. And part of it, I think, is this language issue. Part of it is that the information technology industry, and I think you're both members of that,
Yes. Yeah.
and
Right.
perhaps many of the people listening, has actually not produced the goods. You know, if you read accounts by economists are still hopeful that the so-called digitization of our economies will produce a great productivity dividend. Well, let me remind you that the use of computers in industries and offices started when I was a graduate, even as a student in the 1950s and 60s. Computers were coming in. So there's been a steady rise in the use of computers in our society, but it's not contributing a productivity improvement. And that, I believe, is because we have got sidetracked. And, you know, the answer to that question is that no amount of gigabytes will produce a mango. All right, but we need food. And now you think ahead. In around about 30 years, we have to reduce global emissions to near zero. We also have to become far more productive with our use of materials. We will run out of readily mined materials. You know, our iron ore reserves in Western Australia will last another 20 or 30 years. All right, as we know. Now, sure, there'll be new reserves discovered and so on, maybe under the sea or what have you. But we have, as we go on, it's getting harder and harder to find mineral resources. So the prices will go up. We have to become more and more clever about the way we use materials. We are using up the biological resources of this planet far faster than we can sustain. You know, fish populations are declining. Arable land is getting, you know, wherever you look, we have a sustainability nightmare ahead of us.
Yes.
The only way out of that is to become far more productive. We have to return to focusing on productivity, real productivity, producing food, clothing, shelter, all the things that, physical things that people need. And sure, information technology and software can make all that more efficient, but it's really incidental. It's a side story. And I'd leave this question with you. You know, people say that information availability is growing exponentially. You know, we're filling up data centers around the world.
Yeah,
and
absolutely.
we don't worry about the energy we use for those. But as the availability of information is growing exponentially, its value must be decreasing every day and will become vanishingly small. And hence, the information technology industry will find itself without a value proposition. Think about that. What you are working with in information technology is decreasing in value as we speak. So why not think of getting into something else?
Powerful words there.
Yeah.
So
confronting even.
What I'm curious about is, because you're talking about productivity, but you're tying it into, you know, making food, making shelter. How do you measure the productivity of what we do?
That's a good question. So this productivity is a macroeconomic measure that's used by economists to evaluate how economies are traveling. It's basically defined in terms of the value of goods and services produced for a given amount of human effort or human labor. Yep. On the one hand, that's labor productivity. And on the other hand, the capital that's needed, land, materials, energy, and so on, that's called multi-factor productivity. And both measures have been growing, but very, very sluggishly. Labor productivity particularly. Now think about it. You know, we as engineers, one of our jobs is to produce the tools and equipment and software that makes people more productive, huh?
Yeah, I think that's the
yeah, but it's not working.
The core reason, isn't it?
Yeah, look at U.S. labor. I mean, I just discovered this the other day. A new set of U.S. labor productivity statistics came out. You know, but around about 1% productivity growth, a little bit less, I think about 0.7% a year, up until 2005. Since 2005, the total productivity growth for labor in the USA has been 0.4%.
What happened in 2005?
Facebook, Google, you're in trouble. Because sooner or later, people will figure this out. And then these companies will be worthless.
What about with more social interaction going online? So more business and people's kind of day-to-day lives are actually spent virtually now. Do you see that kind of reversing at some point?
Yeah, I mean, this is just a temporary phenomenon because of the virus. And look, in some ways, we should all be very proud of ourselves, particularly the IT community. You know, when you see kids in school in villages in Indonesia being taught remotely by Zoom in this time of crisis, you know, we have built something that's extremely valuable, and it enables education to continue. But it's no substitute. It's better than simply stopping schooling.
Yes.
But let's take, if you like, a deeper look. So one of the things I've noticed in my studies of young engineers is that it's very difficult for them to collaborate, and quite often they don't want to. and a lot of this revolves around misconceptions about the use of email and text messaging. You know, a young engineer who read my latest book, which is just about to come out later this year. It's called Learning Engineering Practice, and it introduces young engineers to effective ways to practice engineering. And one of the things emphasized in the book is that if it's possible, you want something to happen, go and ask somebody face to face. And he said, you know, I've tried it. It's absolutely amazing. I get so much more done in the office because I go and talk to people face to face, and other people send emails and complain that they never get read, never even get opened. So I started asking myself, this was some time back, why is it? Why is it that people are relying so much on emails? It's not just engineers.
No,
you know, I mean, I've seen many organizations being managed by email and text messages. And then a few things clicked, and, you know, I can't prove this. I'm hoping that a new generation of education researchers will get in there and either prove me wrong or find a better explanation. But I think it goes something like this. When you're at school and university, you know, the key events, thinking back to it, those moments when we got our exam results. You know, before the age of computers, I can remember wandering around the windows of the Undercroft of the Winthrop Hall, because the exam results would be printed by computers and would be stuck up with sticky tape on the inside of the glass, and you as a student would wander around looking at the windows trying to find your name. And eventually you'd see your name and you'd see the subjects that you had passed. Subjects that you failed weren't even listed. So you could tell how many subjects a person had failed because you knew how many units you had to pass that year. And if you had to pass 8 and somebody only had 3, you would know that they failed 5 subjects. You know, but the point is, these were moments of great elation or maybe great relief. Gee, I passed something. You know, and over time, we got to associate the performance where we sit down and write essays or sit in exams and we write, and a little while later there's this elation, I get a result. In other words, grades are the rewards in education. So, and there's nothing new, you know, this has been going on for centuries. People who have more formal education get to associate writing with value.
Yes. Because
it's writing that produces the grades by which you're judged. So when we get out, we have an ancient tendency to want to write. If we want to communicate, we want to write. And in the 18th century, 19th century, you will see how many people, well-educated people, you know, collected letters and published their letters. They communicated in writing as well. But, you know, before the age of mobile phones, writing took time, effort, and you actually had to pay money to get your writing to the person who has to read it. You had to put it in the post or send it by courier, or sometimes you had to pay a typist to type it neatly, so on. So it was effortful. And you know, particularly in running engineering organizations, actually going to talk to somebody, it saved so much time and effort that that's what people did. You know, at the very worst, you could pick up the phone and call somebody. Then smartphones arrived, changed it all, because now text communication is fast, free, and easy. So that inhibition to using written communication has melted away with technology. And that coincides with this loss of productivity growth. Is that just a coincidence? I don't think so. Because productivity, particularly when it comes to engineering, is all about effective collaboration. Now, we engineers are in trouble. Our reputations, to say the least, have been shredded. Now, remember O'Connor completing that pipeline project at 8% over budget?
Yes, of course.
All right. Major engineering projects around the world, it's not just Australia, around 1 in 6 are complete write-offs.
Mm.
In other words, the investors walk away with nothing. 1 in 3 succeed, provided you set the success criterion as being that the investors get at least half the return they were promised. Only half. Right?
Yeah.
If you said 80%,
like success, yeah.
the success rate would be practically zero.
Yeah.
Yeah.
So, and the reasons why these projects fail, so many of them, lies in collaboration weaknesses. For example, inadequate checking, right? Inadequate, I'm sure you're in software, right?
Yes.
Mm-hmm.
Okay, so one of the important things in software is testing. Why do so many software projects fail? Well, you know, it's really difficult to test software thoroughly, but so often it's not tested thoroughly. In fact, a lot of the time it's tested by the person who wrote the software. Okay, it's a fatal mistake. You know, in engineering, at least the checking is done by somebody else. But what we found, you know, this started with one of my students. He went into a firm for his vacation work and told me what he was doing. He turned out he was doing design checking. And I said, what? You, the least experienced person in the whole firm, are checking designs of other engineers? This should be done by the most senior engineer, not the most junior. So that led to a couple of investigations. We did research on 2 quality assured organizations. Now, these are organizations where all the checking has to be documented, recorded, filed, and then those records are checked by the same companies that do financial auditing. They go through and check rigorously that every little thing has been checked, right?
Mm-hmm.
What we found was that the checking was not being done.
Like, at all.
Engineers had signed their initials in the boxes, ticked the boxes on the computers, had filed the documents to say that yes, I have checked these documents, but actually they had not. And one of the organizations was so proud of their system, they actually gave us a pile of documents and said, look, you can look through these. You know, 10 minutes later, we'd found missing diagrams with print that was far too small to read, missing pages, whole sections that were blank or missing. Elementary mistakes that could have been checked very, very quickly, but clearly were not. And when it came down to it, we asked the engineers, you know, well, what's going on here? And the really interesting thing is that they attributed all the mistakes to outside players. They would not admit that any mistakes were made by their own organizations. And so we found this amazing sort of, if you like, can of worms or Pandora's box. And when we wrote reports about it for the companies concerned, when we presented those reports, they refused to talk to us ever again. They were so embarrassed because their reputations depended on them giving the impression that they were rigorous with their checking. And so eventually I said, well, there has to be some systematic reason. This is kind of behavior which turns up in every engineering organization that we found. I have not yet found one which has managed to get on top of this. And I think it comes down to something which I researched after I was finished researching what engineers do. Well, I haven't really finished that, but I moved on to consider the question, why do engineers do what they do? And more importantly, why do engineers not do what they shove aside? And one of those things they do not do is checking. And so it comes down to perceptions of value. Engineers think that checking is time wasting, costs money, and delays projects. Mm-hmm. That's an instinctive reaction. Whereas when you look at it from the investor's point of view, checking, which is basically giving some assurance that promises that are being made will be kept, is actually a very valuable activity. Mm-hmm. And it makes me feel much better if I know everything has been checked. I feel much safer investing my money. So checking creates real value, but engineers can't see that.
Yes.
Because no one teaches engineers how to create commercial value. And that then leads to the frustrations that I have heard so often from company owners, senior management, and so on. For example, here's a quote. And this quote is from an individual who owns one of the largest engineering organizations in this country, totally dependent on the work of engineers. And he said, whenever I find an engineer in my organization, I sack them on the spot.
What?
I am so disgusted with engineers. And another one who said a similar position, but he wasn't actually the owner, he was the boss, who said that engineers frustrate me immensely. They simply don't understand the commercial realities of this business. And it's true. Engineers are never taught. And one of the really interesting things that came out of our research was the discovery that there is almost nothing published on how engineers create commercial value. And unless there's a theory, you can't teach it. Right?
Yeah.
So there we have it. So part of my work over the last few years has been to publish papers and a guide to engineering value creation, which is available on my website for anybody who's interested. It's been a fascinating journey.
How do engineers create commercial value?
Good question.
What's the answer?
What's the answer? All right. Well, I think I describe it like this. And look, somebody else might come to this research and come up with an entirely different explanation, but I think the ideas would be similar in some ways. Okay, there are three ways. The first is engineers create real value because they create ideas and plans for projects which investors put down money to fund. So $1 billion project, all right? The fact that investors have put up $1 billion to make it happen indicates the engineers have produced value because the investors are happy to pay for that. The next step is delivering value. It's one thing to have plans for a project and the investors are prepared to part with $1 billion. It's another thing to end up with a project which is worth $1 billion at the end of it, or perhaps, or hopefully more.
Yeah.
And so that ability to convert ideas into reality is within the budget and on time is definitely producing value. That's what I call value delivery. And the third is equally important, which is value protection. So much of engineering is about protecting existing value, maintenance, for example, environmental management, protecting the value of the natural environment, defense. Good defense equipment, we hope it never gets used. All right? We spend billions and billions of dollars on submarines, aircraft, and fancy defense equipment. But why do we spend that money? What's the value if it never gets used? Well, the answer is that we are protecting value in our civilization, in our cities, and our people, because that defense equipment deters other people from destructive behavior. And even if there is conflict, good defense equipment limits the amount of damage you sustain during a conflict. So that's value protection. So I think that those three to me summarize it. You know, value creation, value delivery, and value protection. And part of that, one of the important parts of that is that it's ultimately all about the perception of the investors and the customers.
Yes.
Did they get good value for money? Was it a great experience? These are all subjective perceptions. So value in the end is a perception, and it's tied in with emotional behavior, emotional reactions. And that's a real struggle for many engineers. You know, to think that all your work, which is deterministic, driven by numbers, software that's repeatable, in the end, it comes down to subjective perceptions. But that's the reality.
That's very true.
You know, people put up money because they think it's a good idea, not because they're engineers and they analyze it.
So
Probably wouldn't if they were.
How do you teach that commercial philosophy to engineering experts or students? You know, how do you communicate that?
Well, once you've got it written down, it's a great start. So one of the difficulties we have today is that engineering schools think that anything to do with finance is a matter for the business school. You never hear money mentioned in an engineering school. Is that right?
That's right. I can confirm.
Okay, good. So, and you go to a business school, and if it's anything technical, they'll say, oh, that's engineering. Nothing to do with us. We don't understand it. And one of the fundamental things in education is that students can't see connections. Most students, very, very few, can see the connections unless you actually make them explicit. So now that we have an understanding of how engineers create value, it's open to business schools and engineering schools to use that and teach students. Once it's written down, it's easy to teach, not hard. And of course, I think it's actually better learned in the workplace, because then you're actually confronted with the commercial realities. And so it's there, it's on a website. Go and grab a copy of it and apply it in your own work.
So you mentioned value protection, which is definitely one of the hardest areas we've found personally as a software company to actually sell the value of to prospective clients. It's one of those things that you don't care about backups until you don't have one and you needed one. It's really hard to sell people on testing until they see what happens when you don't do testing. And it's harder. I find it's a really hard thing to demonstrate, because they see the dollar value and they go, is it necessary? And of course, you know, part of our job is to convince them that it is necessary. But is that something these companies struggle with, is selling the value of testing, or are they just not doing it because they themselves don't see the value in it?
Marketing is all about education. And so one of the things I learned that distinguishes really effective engineers, and this is in my book, The Making of an Expert Engineer, is that so much of engineering is about teaching, effective teaching. You know, you have, Alex, you have the case studies, you have the evidence, but you have to teach it. And that means, first of all, understanding where your students are coming from. You know, in university, it's easy. Students want grades. That's it. Very simple. Okay? Yeah. Learn this, you get an extra 5%. Yeah. And students will do it. It's amazing. So the first thing you need to do in selling anything is to understand what the customer is looking for. You know, and in the mid-level of an engineering, you know, hierarchy, what are their important KPIs? Right? One of them is staying within the budget. One of them that's definitely, almost certainly not, is what's going to happen to this project in 5 years' time, because there's somewhere else by then. All right? So it is very hard to get a long-term perspective. So part of this, your challenge will be not only to educate those engineers about your backup security and so on, but also how their work is going to create commercial value in the minds of their company directors. And eventually they might be very grateful, because once engineers adopt the language of value creation, it's amazing. Top management suddenly listens. And they'll say, gee, at last we got an engineer that we can understand. Yeah, it's like that.
Yeah.
I think another thing is to recognize that we as engineers are very poor at constructing an argument in words.
Yeah, can easily do it in math.
Yeah, you can easily, exactly. Yeah, I see it a bit like this. And to this, I owe one of my graduate students a great debt of gratitude. He said, when we argue in mathematical terms, it's a bit like building out Lego. The blocks will only fit together in certain ways. And it's easy. You can just figure out it'll go this way or that way, and that's it. But when you're arguing with words, particularly when you're writing or speaking, you're essentially arguing with the bricks, which is, if you like, the facts. All right? But the bricks are smooth. And the mortar or the glue that joins them together is the logic of the argument. And that's really hard. And it's really interesting that in surveys of critical thinking ability, which is something fundamental in universities, engineers come out the worst. Wow. In fact, the limited evidence that we have shows that both creativity and critical thinking ability amongst engineering students declines through their education. It doesn't get better, it actually gets worse. And so it's no wonder that when engineers make a presentation to a management board or group of directors or investors, they make their presentation, and very often after they leave the room, the audience members, directors, sometimes lawyers, accountants, and sometimes even engineers, they'll look at each other and they say, did anyone understand what they were talking about?
Right.
Right? Did anyone believe them? So, and ultimately, the other side is not only do you have to understand concepts of value creation, you also have to learn that listening to people is the first step in learning their language. And until you learn their language, no amount of speaking is going to convince them, because you start off speaking a different language. So listening is if you like, the single most important skill for engineers. And it's not just listening to find out what people are saying, it's listening to the language that they're using. Because if you want to teach somebody, you save yourself a lot of time and effort if you adopt the language that they speak. So they don't have to learn a new language to understand what you're talking about. So my advice is, if you want to convince people, spend a lot of time listening to them. Take them to the pub, take them out for dinner, whatever. And just listen.
Yes.
Pick up the words and the phrases that they use, and then think, how can I construct my messages in their language?
The listening is such a great point, and I think every single business expert / intellectual who we've interviewed on Tech Society has brought up how important active listening is.
Oh, that's good. I'm glad.
It was a great idea.
Going back to the marketing 101 thing, I think that's really interesting, because going back even further, you were talking about how engineering students kind of lack that kind of market finance kind of education.
Commercial perspective.
The opposite. Yeah, commercials, right? So is that something that's missing from education in the engineering school, or is there room for a new one, which is like technical entrepreneurs kind of curriculum that covers both engineering as well as marketing and finance?
Well, again, it comes down to collaboration. I realized that there's no way that I was ever going to learn how to be good at marketing. So, let's hire a professional team and collaborate. And it's been a really, a fun collaboration. It's definitely fun working with some good marketing people. It can also be damaging to your wallet. An accountant once said, did actually tell me, said there's two people you should never allow anywhere near a checkbook. One is an engineer and the other is a marketing person.
Oh, nice.
But no, it's been good. Now, should you have, is it necessary for engineers to learn about marketing? They need to learn that marketing is necessary.
Right.
and that there are good people who can do it. So it is all about collaboration. You know, like, crikey, one of the things that scares a lot of engineering students is the idea that they would have to be good at maths. Right?
Yeah.
Have you ever had to use mathematics in your working life, John?
Not as much as I had expected.
No.
A lot of it is, a lot of it's already been automated in a way, and the real hard work is the large scale aspect of the work of the project rather than the nitty gritty calculations.
Yeah, you're right. And
Yeah.
a lot of that is computers, but some really good work done to show that engineers do use maths in an instinctive way, a tacit knowledge
Yeah,
way.
that's right. Yep.
So your instinctive ability with mathematics is really important. You know, marketing people have other series of instincts which are totally different.
It's interesting.
And one of the things that I have realized, I'm sure you're familiar, and certainly your audience will be familiar with the Australian government's R&D incentive scheme.
That's right. Yep, I'm familiar with that.
So there's lots, and in fact, there are direct grants available for startups and technology development and things like that. One of the things I've tried to argue with the Australian government is that there needs to be a marketing side to this. Now, officially, the response is that marketing is something which is well covered by commercial firms. There is no need for government assistance in marketing because we have so many good marketing firms. We have a lot of them in Australia. But what I've found is that they have a very significant weakness. If you go back in history, in the 1970s, 80s, and 90s, hardly a month or two would pass without some brand new conceptual product emerging on the market. Microwave ovens, front-loading clothes washers, induction coolers. There were so many technical innovations which came into the appliance market in those 3 or 4 decades.
Yeah.
And marketing companies got really good. In fact, some would say they were too good at persuading people they had a need for products that they didn't really need. But they got really good at explaining new products. Now, in this century, marketing is all about developing and promoting brands. Now, there's some sense in that, because if you're a company like Haier that produces hundreds of different products, it's much simpler to promote the idea of the Haier brand being good. Then when people wander into a shop or they go online to buy something, they see the Haier brand, they say, oh yeah, I recognize the brand, I'll buy that.
Yeah, exactly.
So the brand will then sell lots of different products. But when you're introducing a brand new concept that people haven't heard about before, with a brand that nobody knows, then you need some really clever marketing. And that's what Australian marketing companies are not good at.
Of course.
They've become lazy. They're good at promoting brands. Everything is about the brand. How do you develop a brand from scratch? Ooh, that's tough. So the
very true. That's been our experience as well.
Yeah.
Is it? That's really interesting to hear. Yes. So it's really hard to get marketing people who can put across a brand new concept, and that's why thankfully we've got this really good team. They're very expensive, by the way. Really good team that's come up with these original ideas, and it's been so much easier to sell the product as a result of that. So yes, it does work, and I think there is room for some government support, but that's a political argument, something that you might like to take up. Particularly, Alex, you have that experience yourself?
Well, we've kind of ended up being our own marketing company most of the time.
Which is why I brought up the whole technical entrepreneur kind of approach, because that's basically the path that we've taken, James. From programming, engineering, and now we run a business, and we also have to market products as well. So it's kind of a holistic commercial approach that I'd love to hear more about from you in the future.
Yeah, look, I have to work with our marketing people directly. In fact, for 3 hours this morning, I was working on material that they're going to use, technical material, but I have to convert it into marketing terms so they can use it. So you do have to cross the boundaries. And there's some really interesting research work done there who shows that, what's called boundary crossing is really important in engineering. That is the ability to work with people from who think differently, basically. You need to work with accountants, you need to work with lawyers sometimes, and you need to work with marketing people and salespeople. And understand the differences. And that can take time, but it's all about
the same language.
Learning the language, learning their language. Yep. Really important, Alex.
We won't take up too much more of your time. We always end on a fun question. So
okay.
I think the question I'd like to ask you is, what's your favorite joke about engineers, or what's your funniest engineering story or experience with engineers?
There's so many.
That's a good joke already. He's there.
Yes, there was that. Look, I'm going to do this one. Okay. You remember, John, what the motto of the University Engineers Club is? Hasn't changed.
I just remembered that their logo has something to do with holding beer, I believe.
Yeah, exactly. Yeah,
that's all I remember.
But the motto underneath is non loquis sed facere, which basically means people who do not talk but do things. Right?
Oh, okay.
And of course, engineering is all about talking to people. So it's a wonderful joke that, in fact, that motto not only consigns you to alcoholic, or the logo consigns you to alcoholic oblivion, but if you take the motto seriously, it'll consign you to engineering oblivion, because if you never talk to anybody, you're never going to do much good as an engineer. As one really insightful maintenance engineer said, no amount of engineering calculations does any good for anybody until a fitter uses their tools differently, which captures the whole idea that engineers are only as good as the degree to which they can influence others. So engineering is an influence game. And to be good at influencing, you need to be a good listener and listen carefully to people so that you can work out what are their pain points, what's going to get them to move, and how can I address those pain points and make life easier for them? And then they work for you rather than the other way around.
So in a really nice soundbite, what would be your advice to young engineers or aspiring young engineers?
Read my books.
Perfect.
And learn.
Excellent.
So these books, are they available? Are they coming out this year?
Okay, so the Making of an Expert Engineer has been out since 2014. It's not cheap. I think on Amazon it costs about $150 or something like that. But I assure you it'll be a really good investment. The only thing is that it's 600 pages long and it's really dense in many places. So to answer that, I'm introducing a new book later this year. It's called Learning Engineering Practice. Targeted at the first 3 years of an engineering career, but I think that any young engineer could learn a lot from it. And the whole idea is to convey more ideas, but convey them very simply and in a way which is easy for people to pick up. And that should be out in September. I haven't got an actual date yet. But if anybody's really desperate, I'll let them know more details of what's in the book. It includes a comprehensive chapter on how to get a job. Now,
excellent.
I think I'm going to put out a plea here. One of the challenges that we're all going to face over the next few months is there's going to be lots of young engineers coming out of schools and unable to get jobs because of the economic uncertainty. Now, we would be shooting ourselves in the foot if we didn't do something to keep them interested and to keep them learning. So I have this idea of getting people who are perhaps underemployed or even unemployed engineers, because there's quite a few engineers who've lost their jobs, and getting a volunteer task force in place to help these graduates start making this transition from school to the workplace by learning standards, learning techniques, learning stuff that you can teach out of the workplace. Listening skills, for example. So my book is partly targeted towards them, but it also needs a lot of volunteer effort to go with it. So I'd like to put that thought in your minds. How can we help these young kids and make sure that they don't get discouraged and go off and drive taxis and then never come back to engineering when we need them. And we will need them for sure.
This reminds me of back in 2008 when the GFC hit. As soon as I graduated, it was a similar kind of feeling, but this time will be much worse. And
yeah. So there you are, John.
Yeah. It's just happening.
I need you. Yeah, get your community working on this.
Yeah, that's a big passion for us. So we're right there with you. Any help we can actually give you we'd be really happy to.
There you are. Good challenge.
Great.
All right.
Thank you, James.
Thank you so much, James. That was a really good talk. And I'd like to get you back when your book comes out and especially talk about helping engineers get jobs. I think that's
we'll do that.
Really interesting subject. Yeah.
Sure.
Excellent.
It'd be great. And fun to talk to both of you, particularly John. It's wonderful to see you flourishing.
Yeah. Thanks, James.
Great. All the best then. Take care.
So much,
bye.
James.
Bye from Wandering.
See you later. That's the end of another episode of Tech Society. We hoped you enjoyed it, and we welcome comments through our Twitter at Tech Society. Also check out our other episodes at techsociety.fm. Meanwhile, you can check out Close Comfort at closecomfort.com. James's book, The Making of an Expert Engineer, is available at the usual suspects such as Amazon, Booktopia, and the Book Depository. His new book, Learning Engineering Practice, will be available later this year.